Hello students, I hope everyone is in good health. Today I will start the new chapter, Analytical Chemistry. Now, the analytical chemistry, from the term analytical comes the word analysis. Analysis means what? Analysis means determining the chemical components present in the given unknown sample. Unknown sample means any sample, it will be given in the form of salt solution, or in a chemical, all are chemical compounds. So the chemical compounds which will be unknown to you, how will you detect them? That detection, determine, how will you determine them? This is the process, by process analysis we will determine. Because we know that any compound is having two parts. That is, the one is the cation, another is the anion. Take an example, suppose I take sodium chloride. Then sodium chloride is having two parts, Na plus and Cl minus. This is the cation, this is the anion. So how we will detect that the given unknown solution is carrying which cation and which anion? This determination is known as the analysis. By the process of analysis, we will detect this. Now, analysis are of two types. One is qualitative, one is quantitative. Qualitative means what? Qualitative means identification, that you will identify the unknown substance. That means the given sample is having two types of cations in them. Then how will you detect them? By various tests. Then this process of testing the unknown substance given to you, the unknown sample given to you, how will you detect the cation and anion present in them? By the process, different tests and all. That process is known as what? Qualitative analysis. That analysis that we are going to do, that is called qualitative analysis. What is quantitative then? Relate with the word quantity. That means what is the composition of the given sample is having. That means how to determine how much the amount has been given, what is the exact amount has been given in the following compound in the given sample. It can be compound, it can be mixture. We will see the qualitative analysis of the given unknown sample. So, qualitative analysis means, I have already told you, that identification of the unknown substance. That means whether the given compound is having what cation, what anion, that will be detected by the qualitative analysis. But it needs the help of some other chemical test. That chemical test we have to do with the help of reagents. Reagents are the substance which react with another substance. That means it acts as a medium, and it will give you the respective product that will come out as a precipitate or as a solution with a differentiate color, so which will be very easy for us to detect the given cation present in them. So, for example, let us take alkali. Alkali are very good reagent in the lab. That means they are very good laboratory reagent. For example, you know the very good alkali are the potassium hydroxide and the sodium hydroxide. And another alkali we know, since it is weaker, but then also very good alkali, and it is always present in the lab for the doing certain types of chemical tests. So whenever we do any chemical test, we need this alkali very frequently. So why this alkali acts as a, because it always gives the respective colored, it gives respective colored precipitate of what? Hydroxide. What it gives? The respective color precipitate of hydroxides are formed, and in this way we detect what? The metal. The metal comes out in the form of hydroxide. Okay, so that means if I take copper, then copper hydroxide will come out, and copper hydroxide is a precipitate. So in this way we can easily detect the cation present. Okay, now in this way we find that the alkali are the very good laboratory reagent. It comes out as a colored PPT of the metal hydroxide in this way, so that when the PPT comes out in the form of the metal hydroxide, in this way the metal can be easily detected in the form of cation. Now students, you can see the periodic table of the elements. Why I am referring the periodic table? Because you know that in the class 9 you have learned the periodic table. Now we are referring this in order to know that the periodic table is having the three parts. That is, the one is the representative elements, that is the group, it is there. Representative elements are which elements? That is the elements of group 1, 2 and then from 13, 14, 15, 16, 17. That means these are all what? Representative elements. Now representative elements, why I am referring this, in order to know the color of the given cations. Because I have told you that the cations come out in the form of respective hydroxide, and this respective hydroxide can be white, can be colored. Then how we will come to know that which elements are going to give colored and which elements are going to give white or colorless precipitate, white precipitate you can say. Then let us know, and in the lower class we have learned about the representative and transition element. We will refer those from the periodic table. Now group 1 and group 2 and group 13 to 17 are always refer to representative element. Now remaining is the what? Group 3, then group 3 onwards to group 12. That means here, this part, the elements which are present, they are all transition element. That means transition metals, and these are all representative metals. Now on the basis, and these are lanthanides, actinides, we already know, but here we will refer the representative and the transition elements for knowing which will give colored and which will give colorless or white precipitate. So representative elements in their hydroxide form, they will give the white precipitate or colorless precipitate. But the transition element, that means 3 to 12 group, they will give the colored salts. That means the colored hydroxide they will give. Let us take some examples of the representative and the transition elements. Now let us refer the table given in your book. In order to explain the representative elements and the transition elements, how they show the colorless and the colorful compounds, let us represent them. Okay, so these are the color ions, these are the colored ions. Then these are the colorless ions are representing the cations: ammonium ions, sodium ion, potassium ion, calcium ion, magnesium ion, lead ion, zinc ion. These are the common cations which shows colorless ions, and usually comes out the precipitate in the form of white precipitate. Let us ions, these are the cations. Now coming to the anions. Anions, chloride ions, sulfate ions, hydrogen carbonate, that is also known as bicarbonate. Okay, then sulfide ions, bromide ions, and lastly is the acetate ion. These are the anions showing white precipitate with the reagents. Now coming to the transition, show respective colored ions when they will be reacted with the reagents. First we will see the cations. Cupric ion, show blue color. Ferrous, light green in color. Ferric will show yellowish brown, or you can write reddish brown also. Nickel, green in color. Chromium, green in color. Manganese iron, pink in color. Three of the you can see are showing green in color. These three of the we can easily take out that they are taking out, giving the green color, the precipitate. After that we can easily detect them by further chemical test, so that actually the ions it is. Okay. Now coming to the anions. Anions, permanganate ion MnO4 showing the pink or purple, that means pinkish purple color it is showing. Now the dichromate, that is Cr2O7, that is showing the orange color. Then chromate ion, it is showing yellow color. So these are the very common transition elements which are showing in the form of ion, they are giving the respective colors. So students, you have to remember this table very nicely, so that it can help you in writing the reaction with when they will be reacting with the reagents, they will give the respective precipitate in the form of hydroxide, because you know that the reagents we are going to react with the two reagents we are going to do. Reagents are many in the lab, but the two respective reagents alkali we are going to take, that is the NaOH and NH4OH. And NaOH, NH4OH, how they will react with the respective ions and give the respective precipitate out of it, we are going to see out that. We have seen, students, that how the precipitate are forming by the representative elements also and transition elements also. the compounds which are insoluble in water, they form the precipitate. Short form is the PPT. Now, first we will see with the first reagent how this metallic salt, the cations of the metallic salts, how they behave. So, let us see the metallic salt solution action of the first reagent. We will take sodium hydroxide solution. How this reagent acts on this metallic salt solution. Now, this salt solution we will discuss today with few of these cations like calcium, ferrous, ferric, cupric, zinc, lead, lower valency we will take, and lastly is the ammonium. So in this way we will see this all we will discuss in the form of reaction. The first reaction goes with the calcium. How calcium reacts with sodium hydroxide. Let us see first with the calcium salt we will discuss. First is the calcium. Let us take any example. Soluble salt we have to take. Calcium nitrate I am taking because you know that all salts of nitrogen are nitrates and nitrites are soluble. Reacts with sodium hydroxide is an alkali. Both are colorless. This is also colorless. This is also colorless. Now when it reacts, it gives the respective hydroxide. Double decomposition going on. Respective hydroxide will be given. That is CaOH whole 2, and this is a precipitate. Now, as calcium is a representative element, this precipitate will be white. Okay. Now, plus what is the other salt will be formed? Sodium nitrate, NaNO3, and it is also a solution. It is a colorless solution. So, what is the color we get in the form of precipitate? Is a white PPT because calcium is a representative element, it forms. When we add in a dropwise manner, the precipitate forms. Now when we start adding more and more in excess, it is in little amount. This is the little amount. But what about in excess? When we will give in excess, since you know calcium hydroxide is sparingly soluble, it will not get soluble fully, some will be insoluble, so it is white, sparingly soluble. Okay, so this is with the calcium salt we get that in little amount what happens, the white PPT is forming, and when we add excess the sodium hydroxide solution in it, then it is sparingly soluble, but the white it remains as a precipitate in light amount. After calcium we will discuss about the ferrous. Ferrous means Fe2+. That means ferrous salt. We can take ferrous sulfate. So let us take FeSO4 plus NaOH. Okay, students see. This. Now FeSO4 plus NaOH gives what? Again the hydroxide will be formed, but when hydroxide will be, it will do FeOH. It is also a precipitate. But since it is a ferrous I have told you what is the color will be. It is a pale green, or you can say dirty green color. Dirty green precipitate. Plus, what is the another salt? Na2SO4. Okay. So, this is in that small amount. Then when we give in excess, then what will happen? The green precipitate will remain in excess. What happened? When we give in excess, the dirty green precipitate remains insoluble only. Thus no change will be found. Okay. So this is about the ferrous salt. Ferric salt. With the ferric salt, we will see that the ferric ion, how it will be changed. So let us see with an example. FeCl3 ferric chloride plus, again we will give the NaOH. Okay, now FeOH whole 3 and C whole 3 it will be, then it will be 3. FeOH whole 3, it is a precipitate. So what will happen? It will be a precipitate plus NaCl. NaCl. How many NaCl? 3 NaCl. Okay, ferric chloride is reacting with alkali sodium hydroxide, then the precipitate of ferric hydroxide is formed, and ferric iron is giving what color? The ferric iron is giving reddish brown, or you can write yellowish brown, reddish brown. Okay, so when we start adding in dropwise manner, so the precipitate is forming. Now in excess, when we add in excess, then what happened to this precipitate? Precipitate get dissolved? No. Precipitate remains insoluble. Just like the ferrous, we find that it remains insoluble. Now coming to the next point, that is the copper salt. Cu2 plus, that is we are taking which ion? Plus 2, that is the higher valence. So let us take an example. CuSO4, very well known example. NaOH gives CuOH whole 2 plus Na, here it will to Na2SO. It is a solution, okay, it is a precipitate. What color precipitate? Copper salt gives what? Blue PPT. Pale blue PPT will be formed. Okay, now when we will add in excess, then what will happen? In excess, when we add the reagent to the copper hydroxide solution precipitate, the precipitate remains insoluble. No changes formed. Clear? Now coming to the next. That is the zinc salt. Zinc salt, that is Cu2, Zn2 plus ions. Zinc salt is giving what? Any example you can take. I am taking zinc sulfate, okay, plus NaOH. Again it will give the hydroxide ZnOH whole 2 plus Na2SO4. Now this is a precipitate, but since zinc is a representative element, the precipitate will be white precipitate. But what type of white precipitate? It will be gelatinous white precipitate. Means it will be a bit shining, glycerin type of shining, gelatinous white precipitate. And others, all three are colorless solution. Now coming to the next, that is the lead salt. Lead salt we will consider here the 2 plus ion, lower. Lead is the having 2 valencies, that is the 2 and 4, but we will take the 2 valency. That is lead nitrate. You know also all salts of nitrogen are soluble. So lead nitrate plus NaOH gives PbOH whole 2, then it has to be 2 plus NaNO3. NaNO3 having 2 is there, so it will be. Now it is a precipitate. Since lead is also a representative element, the color will be white precipitate. Now in the zinc and in the lead, we have seen that they are forming the precipitate. What about the excess of the reagent when it will be added to the gelatinous white PPT? Then we will see the changes. The white PPT, this gelatinous white PPT gets soluble. Now similarly with this one, this is a chalky white precipitate. In excess when we give, then what happens? It gets soluble. Clear? Now coming to the last of this, that is the ammonium salts. Ammonium salts having the ammonium ions in them. Now you know that one thing, ammonium salts whenever reacts with caustic soda, or you can say sodium hydroxide, it always gives ammonia gas. This is the specification of ammonium compound. Now let us see the example. When ammonium salt, any salt you can take, I am taking NH4Cl. When reacts with NaOH, gives what? On heating, it will give NaCl plus H2O plus NH3 ammonia gas will be evolved. Now this is a very important also, that this reaction gives the ammonia gas when reagent reacts with ammonium compounds. Any compound, you can take ammonium sulfate also, ammonium chloride also, and like this we proceed with them. So they are giving the, and these all are solution and giving the ammonia gas. Okay, so this is all about the reaction of the sodium hydroxide solution behaving as a reagent with few of the cations. We have seen how they are representing, how they are. So in this we have seen the 6 and 7 salts we have seen, in which the cations come out in the form of hydroxide. Some are coming, the representative elements compounds are coming out in the form of white PPT, and the transition elements are coming out in the form of colored PPT. The colored PPT, I have already shown you the box of your book, only it is given, the page number 64. You please go through them very nicely. It will help you out in remembering while doing the equations. So students, that's all for today. So keep learning, keep practicing these reactions nicely with this all varieties of the cations which I have taught you today. And in the next session, in the next video, I am going to give you the action of ammonium hydroxide on certain salt solutions.